Hi everyone, welcome back.
Hi.
We are very happy and eager to see the games that have been developed during these 2 intense days. And so here we are.
Good afternoon, Kat. Good afternoon, everyone. There have been really 2 very intense days and nights because our jammers, they did work hard even during Friday night and Saturday night. Of course, as always, during the Quantum Game Jams. So they did wonderful work. We have 4 teams. Very creative ones, and they have done a wonderful job that we are going to see together in this afternoon. But before going to the games, we are going to introduce a very special guest, right, Kate?
Yes, we have with us Zehi Seskir, who is a PhD candidate at the Institute for Technology Assessment and System Analysis in Karlsruhe Institute of Technology. And Zehi is also the co-coordinator of the outreach pilot of the Quantum Technologies Education Flagship, the European Quantum Technologies Education Flagship, together with Marilu. So, hi Zehi, we are very pleased to have you here today.
I'm very pleased to be here as well, and I apologize for the noise if you are getting any because there's some construction going on.
Well, Zeki,
Yeah.
this quantum game jam is really weird as it must be. We cannot know whether, for example, Sabrina will parachute herself today from some airplane after the entrance she had on Friday afternoon. So, everything can happen. Don't worry. We
Okay, thank
also have to say, Kate, that Zeki is one of the founders of Q-Word. So he's
True.
really one best person to introduce this session about this closing event. And Zeki, would you like to tell us your view about quantum games and how they can be useful in our education and research system?
Yeah, of course. Well, I can briefly start with introducing the pilot that we are co-coordinators of. It is a pilot under the QT-EDU Coordination and Support Action, and it is called Quantum Technologies Education for Everyone. But it's an outreach pilot because within the pilot we want to explore, identify, and maybe even help develop quantum outreach methods that can be integrated with education efforts. And quantum games are really a perfect example of these methods and these novel opportunities, because I think quantum games are not just educational for the players, but especially educational for the developers of these games. And we keep seeing this effect on each quantum game jam, quantum hackathon, quantum game hackathon, that people are, especially developers, are actually very satisfied and they want to learn more about quantum technologies after joining these. And while developing a quantum game, and I'm sure that the developers here have already thought about this, but you need to think on what separates it from a classical game, which was just a game until quantum games came along. And while doing that, you have to think on the core game mechanics, how physics and games are connected. And I think it opens new opportunities to learn and to explore what games are and what actually quantum physics is about. So I'm really excited about seeing the games that are developed in the last 2 days.
Great, and you will also interact with our jammers during the showcase of the games, and you can try and also comment. I'm sure that we are going to have a lot of fun, in fact.
Yeah, thanks. Excited about that.
Okay. And so indeed, we are going to start with the session about the game show. And we, as anticipated since the very beginning, we will have 4 teams showing the games they have thought about, created, and produced. For each team, we will have a pitch, possibly a video, and then some gameplay that will be performed while Zeki Seskir, Nicola Pranzini, Jorge Iagomalo, and James Hutton will interact with them, with our jammers, asking questions and trying the games and commenting. It will be fun. So I don't know whether I'm missing something, Kate. Is that all right?
I don't think so. If maybe since we have a bit of more time, if one of you two would like to comment a bit more on like the activities that we are planning within the context of the outreach pilot, I think maybe it can be interesting also for the audience.
Oh, okay. That's a good time for for showing what we're doing. So first of all, I think that we should say with Zeki that this is one of the several pilots. There are 6, if I remember, that insist on different environments of activity. Our pilot is about outreach and education, but then there are also pilots about educating to quantum physics and technologies in high schools, and then minor and also master in the universities and also companies. So we are the quantum technology education coordination support action that Zeki was referring to is really a coordinated effort all over Europe, and we also have US partners that is really trying to build up a kind of an ecosystem, we could call it, a community, a real community with not only with competencies, but also with a clear idea about which are the competencies that are still missing, that we need to build up and also to diffuse and to disseminate. And about our pilot, Zeki, what to say? That our pilot is something. What is an hypercube? Is a very strange pilot. We go along many different dimensions of action, but really in a very few words, we could say that it is a pilot where we try to build up tools useful to address the activities about outreach and education on quantum physics and technologies, and also to assess the efficiency and effectiveness of these actions. So it is not just about organizing events. That is something that we also do. This is one, because as the logo of the QTE for all pilot, we did it also with a lot of other events like the European Research Night and other quantum game jams and hackathons, and more will have to come. But essentially we are doing research about outreach and education in the domain of quantum physics and technologies, and in these quantum games are becoming really a very important tool that we think can really change the conversation about how to do education and outreach, because we are convinced that quantum games and also tools that somehow are similar to quantum games can be complementary in quantum physics and education, quantum physics and technologies education and outreach can be complementary to two kinds of literacies, the mathematical literacy and the experimental literacy, that in the quantum domain are very poor usually for a generic public, but also in high schools and almost everywhere. So with quantum games we can keep up with the rigor, the scientific rigor of the concepts that can substitute somehow the missing mathematical literacy or complement it to build up intuition, and also provide students or whoever wants to learn these concepts a way to practice the concepts while really going from the abstract and theoretical idea down to the application. And so this is the general idea that we are trying to pursue. Last and not least, we are more than 30 partners all over Europe. There are wonderful persons from the quantum technologies research in academy, but also from schools, from companies, and also from schools at a very, very low grade, so starting from kindergarten. We also have pedagogists working with us. So I think we are we have a lot of enthusiasm, and we really wish to produce tools that can be useful to everyone.
Nice. And also some like beyond the ocean partners as well, because the most partners are from Europe, but there is also someone from the US. So it's even a bit more international. Mm-hmm.
Yeah, we have from the US, we have partners in this pilot in particular from Gila and University of Colorado at Boulder, Eder Lewandowski, who's one of the maximum experts in physics education research. And then we have also an important work going on about the responsible research innovation approach to quantum technologies education, on which we have the expertise of the Georgia Tech group led by our colleagues, and I mean a very important group who is also involved in building up quantum games.
Okay, thank you, Marilu. Zeki, do you want also to comment a bit more, or is it time for the testing part of the games?
I think Marilu summarized it perfectly, and maybe we can just say that there are other quantum game jams coming up. So just, keep an eye out for oncoming events.
Okay.
If you're not tired yet, we have more space for you.
Zeki, why don't you show it?
Sure. Why not? Let me just open it. And as you know, we had 2 in the last 2 months. And can I share the screen? Yes.
I think so.
And there's another one that is coming soon. Can you see it?
Yeah.
Yes.
Can you see the screen? Yeah.
Mm-hmm.
Yeah. So you can just go to the qworld.net, QGEM 2021, and you can just register. It is open to everyone. The deadline is on the 25th of November. And if you are older than 14, you can apply. And you can use your expertise that you gained here, there as well. So just check it out for yourself. And if you're interested, just join. QWorld is also one of the partners in the pilot, so it's still within the pilot.
Great. Thanks, Zeki. Okay, so Kate, what do you think? Are we ready?
I think
what
we
is
are ready.
What is our directing team who's working over our heads? I take advantage to really thank the Internet Festival team, Michele Lanzo, but also Enrico. They are doing
and
a wonderful
also all
job.
the people behind the scene.
Behind the scenes, really. Thanks a lot to everyone. So
But
are we
yes,
ready?
it's definitely time for the waited moment of the game testing, and so
Okay.
I will let the space for our tester that will be Nicola Pranzini, Jorge Iagomalo, and James Wutterenzechi Seskir. So yes, I think you can have the stage now and
Yeah.
direct a bit
Hello,
this
everyone.
part.
Hi, guys.
Shall we
Thank you.
say that they have been patrolling the teams over? Hi, James. They've been patrolling the teams all over night and day, helping and supporting the teams to solve the last problems. And it has been really nice to have all those ping, ping, ping during, say, 48 hours continuous time.
Yeah.
Okay.
Okay, so
So,
guys, the stage is yours, and yes, we are eager to see the games.
shall we just announce, Kate, the two of us? We can go and announce one after the other the four teams. Okay.
Okay.
So we are going to start with the Shadow Priest. This is a very mysterious name. And the quantum game they are going to show is called Polaris. And on stage, please, Ishan Banuka. Are you there?
Yeah, I'm here.
Ishan,
I'm here. I'm here.
welcome. The
Thank you.
stage is yours.
Yeah. So Shadow Priest. Let me just start from that. It's more of a gaming name, since all three of us who make up the team are really into playing video games. So yeah, that's where it comes from. It's less quantum. It's more gaming. But let me share my screen and start off a presentation. Is that are we playing the game first or starting the presentation?
First, the pitch. So yeah, you can start the presentation and describe the game. Then if you have a video, you can show the video, and then there will
Yeah.
be the gameplay with our experts.
Sure, sure. So let me just show the game first a few seconds, and then talk about it.
Sorry if I interrupt you. You have, and this is for everyone, you have something like 10 minutes for the pitch, the presentation, and the video. Okay?
Yeah.
Thanks.
So yeah, this is a build of our game, and it's called Polaris. We basically have two. We basically have an enemy firing bullets towards us. Those bullets are polarized photons. So you have to you have to rotate your shield in a way that you can block the photons from coming and hitting you, right? And it has a groovy music, so it's supposed to be a lot of fun. Yeah. So now I'll go over the presentation and quickly tell you about the team, how we made it, and then we can discuss it in more detail. So that was the game that we could come up with in 48 hours. We had lot more things to bring in, but yeah, 48 hours is just not enough. Okay, let me present. Hmm. So yeah, who are the shadow priests? So they are normal human beings. They are neither priests nor made of shadow. So I'm Ishan. There's Shantam Bora, and there's Tapan. All three of us know each other from college when we were doing our bachelor's in engineering. Now I'm studying for masters. Shantam is going for PhD in quantum physics, and Tapan is a product manager. But we really enjoy playing video games, and we try to apply that energy constructively by making a few as well. So the idea for Polaris came up when we came to know about the quantum jam, and we thought maybe we could combine some concepts from quantum into a fun game. So the idea was to make a fun game and maybe introduce a few concepts as mechanics, right? So we had a few inspirations, and that's what I'll describe. So Polaris is primarily a rhythm based game, which means the music plays an important role, and that's what you heard in the background. It's supposed to be a very groovy music. You're supposed to enjoy playing it, and the bullets, the photons that are being fired are actually at certain beats. Like it's in tune with the music that's being played. We found a really good we found a really good tool that actually converted a music file into a data file which had, fire a bullet at this beat, fire a bullet at this time. So we mapped a music file into something that you can see as bullets being fired towards you. And then the concept was that these bullets are actually polarized photons, which means they have some values in two components, and your shield must block them so that neither of the component hits you, right? It's something like it could be halfway along the x-axis and halfway along the y-axis, and you need to position it perpendicularly so that neither of the components get through. Okay. And the mechanics for that was that we have a shield, which can block it, and you press the various buttons. You have Z and X to switch the angle of the shield. You can switch the angle at which the photon is measured, right? So that's briefly about the game. Does anybody want to play it and share what they feel, and then maybe we could discuss where this was coming from and what all other things we had in mind?
Well, okay, thanks a lot, Ishan, also for having been really on time. And so, in fact, we do have also some time for questions from our parterre of experts, if they want to. Otherwise, we can go to the gameplay.
Yeah, no,
Yeah.
I would like to thank Ishan and all the team from Polaris for the great game they have made. And I think that it conveys really nicely this idea of polarization and incorporates that into the game. And I think that also, because the building blocks are simple, you can incorporate other quantum concepts really easily. So you have the photons there, and then you can play with some other quantum properties in further versions. So I think that's a cool piece of game you have there, and that you can, whenever you can develop the next levels, and so you can start adding that complexity level, and also the complexity in the quantum essence of the quantum concepts that you're introducing. So I think it's really enjoyable.
Yeah, and also at first I didn't understand that like the bullets were fired at the synchrony with the music, but that's an amazing idea. It's really fun. You can also redo the same levels with a different music, and it changes completely. The game changes completely. So that's great. Maybe we can someone can play while we
So I can share screen while I talk, and
it is not the easiest game, I have to say.
The right screen,
because the groovy music goes fast.
Hopefully you're seeing things at the moment and hearing me.
Yeah,
both of those things would be good. Okay, so this is the game, and let's see, when you were describing it, is it that I'm supposed to get it opposite to what's going on, like that, or am I supposed to match what's going on?
You have to match.
Align the photon.
Okay, matching it. Yeah, that makes sense. Okay, so it's using this notion of the polarization. Sorry?
It'll restart,
Yeah. So I've got the so it starts off kind of slow, which is nice. Oh yeah, I'm doing well, and then so but it's obviously I've got the sound muted at the moment, but the fact that it synchronizes with the sound is really nice. So that's a good really reason to have it on. Yeah, but and there's a symposium next week, the first symposium on quantum music, where people are trying to use quantum computing to generate music. So it'll be interesting for a future version of this to look into using some of this quantumly generated music as well to add an extra quantum level. But even just as it is, the fact that it uses this polarization concept is something that's used quite a lot in explanations of quantum properties. People often get these polarizing filters as part of their explanations. So it's just a much more fun way to do the same kind of thing. So yeah, I really like it, even though I'm terrible at it.
It's
Maybe
really
there
hard.
should be a toggling
It's a
the
bit
speed for
yeah,
old
yeah.
people.
We are yet to tune it, so people only
Yeah.
get the proof of, you could call it the MVP ready.
Mhm.
We can tune it to make it much more fun. The concept for the polarization part itself, like that was that we were having a lot of discussions about what we could make, and there were at least 4 different ideas until we finally came to the polarized photon thing. And Shantam was like, it spawned like just clicked that, okay, yeah, why not just use a polarized photon, a standard example, and make
Yeah.
it into a game. um,
Mhm.
the music itself is the concept that the music drives the level is from Beat Saber. It's a popular game where the music, it's a much more polished version. It's it has like millions of downloads, but it has the level made from the music itself. And the visuals that you saw, so this game, it's looking pretty because Tapan added his like he designed all the components to look cute and gamey. So that's why it looks a
Yeah.
little bit fun
And those
rather than
those
a normal.
all. Oh, sorry.
Yeah,
Now,
you say?
is all the stuff like on the sides related somehow to quantum, or because I saw there's some boxes and some stuff like that. Is
Yeah,
there some inspiration about quantum stuff, or?
like labs, just
Yeah.
the concept of a lab and
Oh,
robots coming to life or something like that. So
Mhm.
originally the game was named Quantum Duel. It was two robots fighting using photons, but we named it Polaris later. If you could share so the music is also is by somebody called Kevin McLeod. He makes really good copyright free music, so if you can play it for everybody, you'll see that it's very groovy. Like choosing a music for a rhythm game is quite important because you really feel it. The music makes it much more fun. Otherwise you're just pressing keyboard buttons.
It's nice to see that that's your heritage component on the game through the music.
Yeah,
In a
I
way.
tried to share the music there. I don't know if it worked, but yeah, that
Maybe.
guy in Compotech, he is so great for music. Oh my god!
Yeah.
Everyone should go
maybe
to his
maybe
website
I
and
can
check it out.
share it. Let me try to share the music. Can you hear it?
yep.
Yeah.
Yeah, so something like this. Yeah, so it's pretty difficult right now. But we had like we could tune it to make it a little more easier, little more human to play. It's right now it's super fast, and we
Mhm.
had a plan to add one other concept, entanglement, basically where two photons are entangled, and when you measure one of them using your shield, the other one gets the operation is applied to that one as well, so it changes its state, and so you have to
Mhm.
account for that. So that we couldn't add that one, but I think that would really add a level of complexity and fun to it. So yeah,
Mhm.
that's a future plan, you could say.
It is beatable. It is beatable. I think one cool thing that at the moment, I think the photons, after playing it a few times, I could see that I think the pattern is always the same at the moment. So I
Yeah.
could start to see more or less, and I could beat it. Although I died once with the spare photons left. So I already blew the other tank, but there were photons still on the screen, and it was like a draw, I guess. We both
I
died
have to
there.
say we were playtesting the games with Jorge before, and he was trying so hard to win. He played the game
Yeah.
like 10 times. It was like, I have to win.
Now I'm just watching the pattern.
Yeah.
These guys will die, but one will come soon. Okay, I'm going to stop sharing now because
Can I ask a hard question, Ishan?
Sure.
If you have, I wonder if you have in this very short time that all the teams had for developing their ideas, whether you envision how the other dimension we had suggested for the team so the part about the cultural heritage, so to speak, how you can envision to implement it in a future version of this game.
So we discussed this. We actually thought we could incorporate it. If you notice that the screen is scrolling, you're kind of walking through a map, and we thought that we could add certain elements of maybe major developments in quantum physics into, like, small images of them, maybe some milestones, logos or milestones, just scattered around the map. So it would be in the background. You would notice it if you knew it, something like that.
Okay.
Yeah.
But also the photons could shine different places in different ways. That could be another direction.
Yeah.
Okay, for the next time. Okay, so thanks a lot to Ishan. I don't know whether do you have other questions or comments? Jorge, Zaki, James, Nick? No?
Yeah, no, I think you did a great work. And also, can you hear me? Because I had some problems with my connection.
Yeah.
Yeah, okay. And also, that's a shame that, I mean, it's 48 hours, but during the development, we managed to see also the concepts for next levels and few ideas for the future. And those are also great. So I'm really looking forward for, if you have time for developing it more, would be great.
We hope to.
Yeah.
Yeah, that's a bit difficult, but we hope to. This could be a good game. Yeah.
Yeah, I mean, this 48 hours issue is something really, awesome. Looks like a magic that in less than 48 hours, because some sleeping is always needed. Teams can work out something that is playable. If one tells this kind of crazy stuff outside this nerd world of ours, everyone, just makes a big eyes, saying, "Really, 48 hours is impossible." Well, they made it possible. So thanks a lot, Ishan. Okay, thank you to you and all the team. Kate, where are you?
Yes, here I am.
Yeah.
And indeed, I'm always impressed at each event of this kind, like each game jam, how people can manage to create something in such a short time, to design it, to think about it. It's really amazing. So congratulations to everyone. But now it's time for the second team, that is Qui Quo Quantum with the game Quantum Trap. And we have Francesco Generali to present it.
Hi, everyone.
Hi, Francesco. Welcome.
So, I'll share the screen. So, presentation, trailer, and gameplay, right?
Yes.
Okay.
Yes.
Share screen. Okay. No. Swap.
So Qui Quo Quantum is wonderful, Francesco. In the meanwhile, we comment on the team's name. Qui Quo Quantum forever.
Qui Quo Quantum forever. And I also, just a brief comment for the non-Italian, because Qui Quo Qua in Italian are the nephews of Donald Duck, but we discovered recently that they have different names all over the world, but in Italy it's Qui Quo Qua, so Qui Quo Quantum, I think is inspired by that, right?
Yeah, right.
I hope so.
Indeed, but please, Francesco, go ahead.
There is not a deep lore.
No.
We are three guys that met each other during this jam. We are junior in our specialization. I'm a game designer. Luca is a programmer, and the name, Mark, the name. Sorry,
Well, you met just for this jam, so
sorry,
you met only for the jam.
And
so
he
it's
hasn't
okay.
slept so much, so we can forgive Francesco.
No, I'm so bad with the names. So and Tommaso is the concept artist. Our game is a first-person puzzle game where you can switch between a world with classical mechanics and a world where only quantum mechanics value. So, and you need to use both of them to solve puzzles and go to the next level. We have done 3 levels. So the first one is based on superposition, because in the not real in the classic mechanic world, the one on the left, you can't overpass a wall, but in the quantum world you have a probability to do it. So I said a probability because in the quantum world you are not a ghost that can go through walls, but as you can see from the GIF, the when you try to cross the world, start an animation that do a casual number of attempts, and one of these attempts do the possibility to overpass the wall. The second level is show that even classical mechanic level have property that you can do in the quantum levels. This is a game design thing, because if we will create a game where only the quantum world had particular mechanics, the classical mechanic level will be useless. So the game will be boring. And so in the second level you can move items to, for example, to create a ladder, as you can see in the GIF. And the last level originally was based on entanglement, but we talked with Nicola, and he suggests us that our idea is more linked to the beam splitter concept. So the idea was to split the player. As you can see in the right GIF, the player find a mirror and can split himself in two. And in this level, you have to active two buttons together, and you can do it only in the quantum world. And this is the last level we have made. In the future, obviously, we could create levels with mixed properties. You introduce more mechanics based on this concept, on the concept that there are things that you can do only in the classical mechanic world, and things that you can do only in the quantum world. And other sub themes in our game, the first one is the things you can do in the quantum world are linked to the big world, are not things that remain only in the microscopical world. And one last thing that is not present on the slides is that in the classical world there is a big eye that look at you all the time. This is because the classical physics is observable, but for example, for Heisenberg, you have a limitation in the vision of the quantum world. And so that's all. Thank you all for your attention and the possibility of this jam.
Thank you, Francesco.
Thank you to you, Francesco, and to the whole team.
To the team, yes, of course. And okay. So the game testers.
The game testers. Where are you?
We are here.
If you want, I record the video of the first level as the trailer. You can find it in the each page of our game, but as you want, it's just the first level.
But I think I can open the game and we can discuss it while I test it. So let me share my screen. Okay. Can you still hear me?
Yeah.
Mm-hmm.
Yeah.
Okay, great. Quantum trap. Okay. Can you see my screen?
Yeah.
And hear the sound as well, right?
Wow.
Okay, so here's the spooky eye.
It's so creepy.
It's really creepy, yeah. And also it's really looking at you. So here's the wall you cannot pass through. And we are in the quantum world. I really like the concept that you don't scale down, you don't become smaller. It's just like following other rules, but you have the same size. So it's not like microscopic versus macroscopic, as we were saying.
And I don't know if you can see from the share, but there are a lot of VFX effect in the quantum world. This distortion, the grain, and other things.
Yeah, I can
they're
see them very
visible.
well.
Me
I
too.
don't know if okay.
Yeah.
So then you overcame the wall via tunneling, and then you're back in the classical world, right?
Our track 9 and 3/4.
Sorry?
So,
I
okay.
got it, Mari.
You got it.
Yeah.
Nick is the track 9 3/4 from Harry Potter.
Oh, okay. So I have to enter the quantum world.
I like the idea that you can only manipulate the solid objects in the classical world, and then you have to go into the quantum one for the funky stuff.
Thanks.
And then try crossing the wall. Here is doing many attempts.
Someone at some point has to make a quantum Sims, where the character of the Sims keeps hitting the wall and eventually tunnels.
You cannot kill them in the pool.
Exactly. They will tunnel out of it with some probability.
Okay, and so this is the last level. This is the mirror, right? So I should press these two buttons at the same time, but I cannot. So, okay, so I need to go here, right? I become quantum. And then it's amazing how can you do, like, you have done all this in 48 hours. It's impressive.
Yeah, I mean, it's just awesome.
And then done.
Press E.
Okay. Oh, okay. So now the other guy is moving with me, but I have to replace it, right? Okay. Come with me. Sorry, I'm not speaking too much, but it's very... Yep.
But he follows. Doesn't speak, but follows.
Yeah. He's the guy in silence. And then, can I jump here? Oh, nice.
You're in the quantum world, Nick.
I need my copy also. Come here. Oh. Nice. Very cool. And there's the eye. Because now I have the classical word, and to end the game I have to press again, right?
Yes.
E. Okay.
Maybe try to pass it with the left one. It's a little bug.
Oops, and that's my fault.
Don't worry.
But yeah, no, it's... I can stop it for the moment. Okay. Any comment? It's great. I mean, the eye, the spooky eye on the ceiling is it's spooky, but it's really cool. Like, yeah.
I'm amazed. I was thinking that indeed the power of doing these quantum games and playing these quantum games, because this fact that to go from classical to quantum, you are not changing the from microscopic to macroscopic and vice versa, is something that really goes at the heart of the concept, and really helps to do education on quantum physics in a absolutely correct and rigorous manner.
Thanks.
And just with a game, so just in quotes with a game. So thanks a lot, Francesco and team.
Thank you too.
Yeah. So are you
Yeah, I have-
free? Oh,
Yeah, I like the idea that you move between the classical and the quantum world. There's different game mechanics associated with each, and then together they allow you to get to your goal. It kind of reminds me of the philosophy of these hybrid quantum algorithms, where people do a bit on the quantum computer and they do a bit on the classical computer. So everything's at the kind of the same level. You're just using the bit that is useful for you. So it's nice to get people into the kind of right mindset for that sort of thing.
Thank you.
Yeah, also how you're using the different levels to incorporate new quantum concepts is really cool as well, because you start with, tunneling, and then you move into things like from a beam splitter, etc. I think that's also a good way to progressively introduce new mechanics in the game that also adds this extra possibility of you slowly familiarizing someone with one of the concepts and then adding a new mechanic that will bring together another quantum concept.
Yeah, that's the idea. Thanks.
Yeah, and also maybe I can add something. I really like the idea of going between these worlds, but maybe just a suggestion. You can connect the gate at the end with the eye that is always watching the classical world, because I think it's just an obvious thing to connect it with the measurement concept. Like, to get out of the quantum world, you need some measurement in that sense. And the eye is an obvious object that can actually perform that measurement.
That's cool. So you mean like I can ask the eye on the ceiling to interact with me and measure me
sure.
for the X
Why
and
not?
Y? Yeah, that's cool. That's cool.
Yeah, that will be interesting.
Of course, I have my usual question. The same as the.
We all have eyes, Marilu, everywhere.
Okay. I cannot be serious. I'm sorry.
No, but now you have to say which is the usual question, because we already understood, but I don't know if Francesco understood which is the question. So, Marilu,
So
be
the
brave
question
enough
is.
to ask it.
Okay, I have to be brave. So no, the question is whether you considered in a follow-on how you could implement this idea of placing the game into a cultural heritage location, or say a space that tells about history and stuff. I think that for the way this game is conceived is much easier, right? In principle. By the way, also the music was wonderful. Well, very well suited, I think, to the setting.
Sorry, I'm not sure to understand the question. The question is change the abstract theme and put the game in a real place with cultural reference. the abstract theme, the abstract concept art is not fundamental in our concept. We got inspiration by Manifold Garden and other first-person puzzle games that in a lot of cases are abstract, and the other there is a second come si dice? There is a second
like
oddio, non mi viene
inspiration.
nemmeno in italiano.
Inspiration or like
Oddio, non mi
Reference.
viene in italiano. Vabbè, we do this game in a minimal theme because we haven't a 3D artist, so we choose a very simple way to create levers. They are just cube, and Tommaso, the concept artist, create the textures that we applied to the materials, so we could change the theme of the game
Very easily.
plus
Yeah,
or
yeah.
minus.
Visual impression.
Yeah.
Yeah.
Mm.
Great. Thanks a lot, Francesco.
No, thank you. Thank you too.
Okay, I think now it's time for the third team, and the third team is the Team Bean. The game is called Bean Jam, and we have, I'm not sure if Simon or Kartikeya are going to join the stage. Okay, hi
I
Simon.
think Simon.
Hi, everybody. Yes,
Simon
so I'm Simon.
Yeah.
Kartikeya is our main programmer. He is the one member of the team who I don't think has had any sleep for the past 2 days. He did most of the coding, but it seems like he's still awake, and we were having problems getting the game delivered to everybody so you could actually run it, but we do have a video. Unfortunately, I just got a message. It seems like he's not able to join because it's full. So I will go ahead with the original presentation as planned.
Okay.
Let me just start sharing my Google spreadsheet that I have prepared. Chrome tab, Bean Jam. Okay, so I'm currently displaying.
Hi, so sorry, Simon. We have also Kartikeya.
Okay, so he's able to join. Okay, great.
After 10 coffees, Kartikeya.
More than 10.
Double Italian espresso. Double espresso. Go ahead.
Well, I'm currently sharing the presentation that we all sort of went over, and I was thinking we could start off by introducing who we are and what we made with this, and then when it comes to actually demonstrating the game that we've created, we can pass it over to Kartikeya. You're all able to see my presentation at the moment? Just checking.
Yes, we do.
Yeah. Okay.
And I like this aspiring quantum computerist that you put on your name.
Okay. So yeah. Personally, I have been a software engineer for most of my career, based here in Singapore and Japan. But it's just been the past few months that I've been studying quantum computing. But anyway, as a team, we are Team Bean. The name of the game that we created was Bean Jam. Jam because, well, everybody has been participating in a game jam for the past, I think, 48 hours. I'm not sure why, but at some point during, I think yesterday, we came up with the concept of Mr. Bean or a bean being the main character of the game. So that kind of stuck. And you'll see in a minute that our main character is a bean. Anyway, so we are a team of 5 people. Kartikeya has been our Unreal Engine game developer. He's been a powerhouse coder and quantum physicist. We've had Oli Delgren, so I'm not sure if I pronounced that right, but he's been a coder and a quantum physicist helping us. I have been a coder and, as you say, an aspiring quantum computerist, and we've also had Nicole Ferrier, who's a quantum physicist. I believe she's in her first year doing her PhD in Glasgow. I don't know what university, sorry. And we have Sanjita Mukund. Sorry, I'm not sure if I pronounced that right, but he's also joined in some of our brainstorming sessions as a game designer. Okay, so let me start off with what the story behind our game is. We call it the Bean Jam story. I'm not sure if it's actually been made public, the theme of this game jam, how it was like, it's not a small world after all and cultural heritage. So we've tried to incorporate those two concepts in the story. Admittedly, we did sort of add it to the story after we implemented most of the game. But anyway, let me read this to you. So you can join Mr. Bean on his epic quest through the small world of quantum to reach an even stranger and unknown realm. With quantum gates as his only ability to navigate the counterintuitive quantum world, he is on a mission to collect keys that some say lead to a realm that is no longer affected by the laws of quantum and classical physics. This law, long since forgotten by the masses of human civilization, comes from an ancient alien culture that refers to this realm as the ultimate observatory. This is a mystical place where the small is no longer small, a place from where the sole occupant can observe every particle in the universe at once without affecting them, and thus being of a truly omnipotent existence and having ultimate knowledge and power. So in this mystical realm, the observer effect no longer applies. Okay, let me give a bit of a brief introduction to the game. So Mr. Bean is literally a bean man. The genre of the game is a top-down puzzle game, and the objective of the game is to collect all the keys and to reach the portal, or the portal. Well, ultimately we want to implement various portals, but we only had enough time to do one, so we have one portal. And the final goal is to reach the ultimate observatory, which at this moment is planned. We didn't actually get enough time to implement this in the prototype that we will show you soon. Okay, so the elements of the game, you use your WASD keys on your keyboard to move forwards, backwards, left, and right. There are color-coded doors, and to open those doors, you need to use the corresponding colored keys, which you can collect, which are based on your superposition, which I'll explain in a minute. There are also turrets, or basically guns, that are firing high-energy photons at Mr. Bean. Okay, so onto the quantum powers. When we were brainstorming, we were trying to think of all these, the weird and wonderful effects of quantum physics that we could apply. Eventually, we only sort of stuck with superposition, but we tried to think how we could also include entanglement, the quantum Zeno effect, quantum teleportation, quantum tunneling. But we soon realized, okay, there's a lot of great concepts, but we do have limited time and resources. So we did stick with superposition. So let me explain a little bit about what quantum powers Mr. Bean has and what abilities he has within our game. Mr. Bean has 2 qubits to use as powers. The first represents him as being dead or alive. So, okay, he's the Mr. Bean Schrodinger's cat type. This is pretty trivial to explain. And the second qubit represents his visibility. 0/I is invisible, or 1/V. When I say /1, it's like 1 or V, is fully visible. When he is visible, the high energy photons from the turrets can kill Mr. Bean. But when he's invisible, they pass right through him. Then the superposition of these 2 states creates a partially visible state, which can be utilized as an offense mechanism against the turrets. Since it will partially transmit and partially reflect the photons, essentially sending it back to the turret if aimed correctly. The last point on this slide is where we introduce the actual quantum gates that we've used. You can use the H, the Hadamard gate, C naught, Y, and S gates on the selected qubit, so you can actually select which qubit you want to apply the gates to. That adds a little bit more of a challenge for further puzzles. And that's how you manipulate the states of the 2 qubits. So the reason we have that is to clear the level without collapsing onto a defined dead state. Because, well, if you're dead, then, well, you're dead and you can't play the game anymore. These gates can be selected using the mouse wheel. So you'll see on the bottom right in the screen, you can actually scroll through the gates that are available to you, and then you can click on the left button to apply the gate that is currently selected. The X gate, i.e. the not gate, was intentionally left out because that would give you an unfair advantage without needing to solve any of the puzzle. Okay, so now we will go on to a sneak peek, a video of, unfortunately, I am not able to play the game locally, and I think, Katikia, are you with us? Are you able to play the game yourself?
I am able to play the game on my PC because it was compiled on my PC.
Okay,
so we encountered a problem. Yeah, okay. So we encountered a problem where, I compiled the project with a particular version of Python, and then it only works with that version of Python if you have that version of Python installed on your system. Otherwise, it's not going to work because the fact that Unreal Engine changed their architecture completely. So there was a lot of technical stuff, a lot of technical errors that happened. And yeah, I can share my screen and show you the game. Okay. Do you see the screen?
Yes, it's working fine.
Okay.
Can you hear the sound?
No.
No.
Now can you hear it?
No.
Okay.
Did you hit? So if you when you share the screen, there's a little tick box that you can tick. So like stop sharing. When you reshare, you can like tick this small box, which means like say it's like share audio or something like that.
Okay. All right. Got it. I guess now you can hear it, right?
Yes, it's working fine.
Okay, so it's a simple top-down puzzle kind of thing. So it's inspired from Chip's challenge, if any of you people know that. It's a very old Windows game where you had to collect these color-coded keys to open color-coded doors. And so you collect this key. You can just open the door, but if you open the door, then you die because the photon is going to shoot you. So what you do is you put yourself in a superposition, but this is not going to help because you're in a superposition of being alive and dead. So we change our qubit, and now we're in the visibility qubit. And now if I open, and half of the photons go through me, half of the photons bounce off of me, right? So I can use this to kill the turret itself if I aim properly. Okay. Takes some time, but doesn't matter. So this is a force measurement, because we need to have some constraints in a game and not give the full control to the player, right? Because the player can do whatever they want then. So we put some constraints like measurement, and then you basically pick up. You cannot pick up the key because you're not visible. You have to be visible to be able to pick up the key. So okay, again we do this. Yeah, it gets a bit confusing because what is not the states but the probabilities, because that's what we know, right? So okay. Yeah, so when we measure, we know if we were in one state or the other. So we have kind of like a random chance of collapsing in either one or the other one. Yeah, I mean it kind of makes for replayability, right? Because So what we planned was more levels for this. So I have to play the whole game. So you can see there are 2 portals, right? So if you enter either one of them, I'm gonna stop sharing because it's a loud. It's a bit loud. It's a bit loud for me. The thing is, we plan for multiple outcomes to have multiple paths, and so you can go. Literally, you divide your universe, and you basically go into other path if you collapse randomly into the other universe, so the player never feels like they lost something and they should restart the game to play everything again, because that can become boring after a time, because if it's essentially a coin toss, right? So you don't want to sit and wait until you get a tails if you want tails. So what we thought was we should give the player an opportunity to go ahead if and see what happens if they get ahead. So you can have 2 parts, and then the story basically branches out. The game basically branches out, and there are a lot of possibilities using this idea, because one of the idea that I thought was, which I was gonna implement in a second level if we had more time and I had some sleep. I did not sleep at all. So what I thought was, we could have some instead of just one kind of photons, we can have 2 kind of photons from these turrets. So there can be some photons which go through even the invisible things that seem invisible to us but are not invisible to those frequencies of photons. So then you'll have to be creative to avoid those kind of turrets, because then you have no option of evading those turrets, right? Because you cannot be invisible, you cannot be visible, you cannot be translucent. So what do? You have to be creative. So it basically creates for a lot of puzzles, and both in the quantum sense and from a game sense. So uh, yeah, just using 2 qubits, I guess a lot of things can be done. So I just threw in a Y-gate there for fun, because it basically changes it's kind of like cheating, because you're flipping the qubit, so where you're going to be. So I just threw it for fun, because it's even though it's flipping, but you're introducing a phase. So um, the, there has, like, it gets some interesting effects. So yeah. So one thing that I also thought of doing was having these states that you use display as a circuit on the top. So what is what state you were in at the beginning and all the gates that you've applied. So like a history, you can see the history of what all the gates that you've applied. So maybe if you're free, then you can work out all the math and then find the state that you're in, so you can exactly go where you want to go. Or if you're keeping track, then that's a very good thing. And so this idea of using visibility as a qubit was suggested by Simon, and I thought it was interesting because visibility is what we use in real quantum systems also, right? So everything that is photonics is based on glass and everything transparent, right? So we can use real quantum systems like beam splitters and stuff for puzzles in this game, and that would basically work as switches. And again, like I said, open multiple paths. So let's say you get the output from one path of the beam splitter. There are 2 buttons for both parts of the beam splitter. So you can have maybe Mach Zehnder interferometers, maybe EV bombs, Elitzer-Weidman bombs, and there are infinite possibilities. And everything just works out because you are the glass. So the photons go through you. So if you change your phase, maybe it's a possibility that you can implement that the photon that goes through you changes its phase. So
And
Yeah.
everything is coded in Qiskit, right? So it's running on a quantum simulation, but it could be run in a quantum computer, right?
Yeah, so this is not coded in Qiskit, but it can be changed to Qiskit. So it's
Okay,
coded
yeah.
in it's coded in it's basically Python. So you can just change this particular so instead of creating the function as a state vector, you can just create the function as the Qiskit quantum circuit and then get the state vector from there, and then it's basically the same thing.
Yeah.
And because
a little bit on the next slides.
Yeah, the thing is that because this Python code is integrated with Unreal Engine in a way that it doesn't really affect the game, so you can change the code and the whole game will change. So if you change the function in the code, even after the game is compiled, the whole game will change in the way that you change the Python code. So it is possible to use a real quantum computer, and I think Simon did some API calls or something like that for that.
Yep. If you like, I can continue with the rest of the slides and then we can jump into any questions you have if you like. Okay, so the current slide is the technology that we used and some of the issues we faced. We ended up using the Unreal Engine, which was something that Katakina has a lot of experience with. I started off by doing a very rudimentary mock-up of just 3 worlds. We were thinking of the theme of like it's no longer a small world, and you can kind of see in the background image the mock-up here. I just had like 3 rooms at different sizes, and we had a little beam on the right. But we didn't end up using that. The final product, as I say, was done with the Unreal Engine. And it is possible to integrate Python with Unreal. This weekend was the first time I had ever actually used Unreal. So it was an interesting challenge. It needed to be version 4.2.3 to get it running, apparently. Unfortunately, we weren't able to get the Qiskit module installed on the environment. So we ended up going with SymPy, if that's the right pronunciation, to actually do the quantum calculations. But ultimately, we could use a local version of Qiskit with the various quantum calculations or the quantum gate functions, etc. But in parallel, over the weekend, I actually took, I created an API server, which is basically using the Flask Python module to wrap around some Qiskit functionality, which I have not put into the slides, but the basic functionality is you can get random numbers, which we didn't use in the game, which can run on a local simulator version of the Qiskit running, or you can actually specify a device, an actual real quantum computer running in the IBM cloud. I found it was the IBM Bogota, I think the capital of Colombia, that seemed to have the least number of jobs queued all the time. So I got the quickest response from that. So I created an API server. Originally, it just started off as with a few functions to expose some random number functionality. You could do a get random int. You could specify get random int 32 or 64-bit. But then we actually added some of the calls that were being used in the game that has been displayed. So I'll come in a later slide as to how we can possibly use that in the future. Okay, so let's sort of reflect upon the past 2 days of game jamming. For me personally, it was my first time to actually ever do a game jam or a hackathon at all. I guess one of the biggest problems we had was once we formed a team, we spent a lot of time just trying to design the basics. What is the genre? What is the gameplay? What is the game mechanics? It wasn't really until well, my time, I'm in Singapore, as I was falling asleep last night, that the rest of the team started to talk about some of the ideas. But then when everybody else went to sleep and I spoke with Katakini this morning, we realized that there was the first approach that we thought we would use was kind of I think it's on the next slide. the first point here. Our original approach was we were thinking of using a mini worlds interpretation. So we thought the player immediately could be split into two. His superposition could be two worlds, and those two worlds could be the left side of the screen and the right side of the screen. But we soon realized that the complexity and the number of possibilities would be just too much to not only just to display to the user, but to actually incorporate an effective game design where we only had 48 hours. So yeah, we ended up spending a lot of time on that. The different time zones made it difficult, but we got through it. And then in the end, after the issues we had with just trying to get Python running and Unreal and all that, we basically agreed, I guess, about 12 hours ago, probably about 14 hours ago from now, on the concept which you just saw implemented in the game that was demonstrated to you just a few minutes ago. So on the last slide, possibly future to-dos. We would like to actually make sure we can get a game that's playable for the rest of the people in the team here. We'd like to make it available on Windows, and because we use Unreal or same with Unity, you can easily make a version for other platforms. We'd like to get an OS X version. I'd also like to actually get a WebGL version up and running so that anybody can basically just log into their web browser and play it. I'd like to actually try and get the Python, the skip Python module running and integrated with the Unreal Engine. But I'd also like to actually integrate the calls on the Unreal client to the local Python code that is calling the quantum functions, to actually making a API call to the API server that I created, and effectively we could then run it on a real quantum computer. There would obviously be a delay in that, it has to queue the jobs and we have to wait for the results. But I still think that could be a way we could actually make our game so it's actually running on a real quantum computer device. Here you can actually see some URLs that if it's running, you can actually click on them and you can see the QRNG, the quantum random number generator. You can specify the minimum, maximum, or you can actually see some basic circuit manipulation by clicking the begin delay, the not, this X0, it's not on the first qubit, X on the second qubit, and then collapse it and see the results. Unfortunately, the characters are garbled at the moment because I haven't got the character set properly in the response from the API server, but that's one of the things I'll be fixing. You can see the source code for this project at my personal repository called Mr. Bean. It doesn't have the actual latest source code, but we hopefully will upload it to there at a later point. That brings us to the end of today's speech. Thank you very much for listening, and just adding a few local thank yous in Chinese and Japanese from, well, because I'm representing, I guess, Asia. I'm not sure if there's anybody else in this region. Thank you very much to all the hosts and everybody who has helped make this game jam a possibility. As I say, it's my first time to join. I've had a great time. I learned a lot, met a lot of great people, so thank you very much.
Thank you very much, Simon.
Yeah, thank you. It was great.
Thank you, Simon and Katikia. Really, it was such a great job. And also, thanks a lot for all the details you shared with us. And also, it was a very, very fruitful also for us to follow all the problems you had to face and all what you solved during this weekend. Thanks a lot.
I think we are running out of time, so maybe we can just do a question.
Go ahead.
Has a question. No, I don't have. I mean,
okay.
What's the name of the team again?
It was called Bean Jam.
The name of the game is called Bean Jam, and the name of the team is Team Beam.
Team Beam,
Team
right?
Bean.
Team Beam, and also I love Mr. Bean, of course, but also your slogan. That it was like, can you say it like the teamwork?
Teamwork
makes the bean work.
Makes the team work.
Makes the bean.
Yeah,
So
teamwork makes the bean work.
I just thought of bean randomly because I was throwing up just a prototype project on Unreal, and then I saw that the default character in any game engine when you start is a capsule, so it looks like a bean. So I just thought, why not?
Right. Yeah.
Okay.
But okay. Do you
So
have questions?
those I have just to say that also the avatar of Simon and of Kartiki are just incredible.
You
the
mean
avatars on
picture
Discord.
on Discord.
Yeah, the avatars on Discord. They
Oh,
are
okay.
really.
But I have to say that like the team was the biggest one, but for the first like 3 or 4 hours, we just called you like the alien guy.
Yeah.
A confession.
And then when the team formed, there was all the other people. There were 5 in total, I think. So it's like, okay, that's the team. But at first was like the alien guy is trying to form the team or whatever.
Also named the other planets guys and the Martians and whatever else. Okay.
Okay, let's
really,
go for
I think I think we have
time
to
for the last
cruise.
team. But thank you very
Yeah.
much, Team Bean. It was an amazing job you did, and thanks for all the details in your presentation.
Yeah,
and now
thank
it's
you very
time
much.
for Team Barton with the game Music. I hope I'm pronouncing right. And we should have Francesco Serace. Yes. Hi, Francesco.
Francesco, you're muted.
Yes.
Unmute yourself.
Sorry.
Yeah.
I am in the opposite situation of the other team. I have a working prototype, but not a video. So I'm going to explain a bit
Okay.
about. I think it was the better part of this game. It wasn't the game itself, but how we come to it, because we weren't here for the Quantum Game Jam. We were here for the Internet Festival, so we went here completely blind. The entire team knew really little about what we were doing, and we arrived here and said, "Well, we are here. Let's try a quantum computing. How hard it can be. If Regia wants to send a laughing track, now it's the moment." And so we began without having an idea about the potential of this technology. So I, in particular, had a lot of trouble trying to find a concept that would be done better with quantum computing, something that would be particular to quantum computing, because everything I was thinking, I always thought I could do better with regular computing. I've later seen that it was a motif on this new technology, as many technology which are still young. So I was having all this trouble. I went on Wikipedia, because that's the better I could do, and I spent a lot of time watching the many algorithms the many known algorithms that were useful for quantum computing, in hope to find something that would inspire me, because I really was stumped. I didn't know what to do. While trying to understand better quantum computing on the composer, trying the various gates and trying to understand what we were doing mostly, we spent a lot of time on the computing just messing around while trying to find a pattern to this madness. And I found that we were having fun. So I thought that all of this searching, all of this trying to find something, but maybe I already had something fun in my hands, because for me, I think for you that are more into this world, it's something really simple. But I was really surprised to find myself having fun while trying to understand what I was doing. And so I thought, if I had a better way to reach the person in front of the screen to send the information that I was seeing, maybe that would be interesting even for someone who would not normally be interested. So we thought, let's try to convey the information through music, because that way we could simplify a complex argument. I'm going to share my screen. I think it's no. Yes.
While you're sharing the screen, Francesco, we can just say that we like a lot the concept you expressed about the importance of the process. This is one of the nice things about these kind of events and about the Quantum Game Jam. And also I want to say that with Nicola, Jorge, etc., we witnessed the fact that you came without having idea, as you said, about this quantum stuff, but you learned very fast.
Thank you. Well, if you see the interface, you can see that mostly it resembles the first part of the composer. We have the H gate, the NOT gate, and the C NOT gate. It's just those three gates because it was a bit complex to implement, so we left the most complicated stuff alone. And we thought, if you can see on the right part of the screen and on the upper right part of the screen, these sliders are the probabilities of the value state, 4 for the two qubits that we are using. This is pretty much an interface, a graphical interface for Qiskit. Because we weren't so good that we could implement API in a couple of days, we simply made a text file. So we sent a text file to a known folder so that the Qiskit parse it and send it back. The problem is that when we went to make the build, the folder wasn't the same for our Python installation and our Unity installation. So that's the reason why I'm showing you the inside the editor. The build still has some troubles. And what we wanted to do was well, maybe if I use the objective, you see it better. We made this correlation between note and state so that we could give a beginning of a song so that you could immediately correlate the final state to something that you could understand easily. In this case, we want to do the note do and la to begin a song. So we want to have a 50% chance of 0 state and 1 state. That's kind of simple, but it's our first level. As you can see, it's not immediate. Our technique is indubitably lesser, and there are problems with the Qiskit, and that we don't understood exactly because we broke physics fundamentally. If I send the gate on the other side, you can see that's 150% probability is not exactly what was meant to be, and it's the Qiskit is doing its job. It's a visualization problem because if I do this, it's correct. As you can see, I don't know if you can hear the screen but we are in an editor, so I'm not sure. This
Francesco,
starts the song.
Francesco, sorry if I interrupt you, just one moment. It's just for those who are not Italian speaking. So the do, re, fa, la, the A, B, D, and C, D, C, D, F, and A notes. Okay, just to know about what is in English. Okay, sorry.
I thought about the translation of the objective, but I have to admit I forgot completely that music
Don't worry,
annotation
don't worry. It's the same.
different.
It's just to have the idea. Okay.
And well, if you heard the song, you know that we completed the tutorial level, and that's it. Fundamentally, we had 3 levels, but we didn't make in time the demo. We saw that if we could make 3 qubits, we could have made an entire octet. So that was something that we really wanted to do. We weren't able because of time constraints, but that's something that would interest me. The one thing I wanted to say is that while doing this, I don't know if it's because I'm not sleeping since 32 hours ago, but it's that since then I've thought that maybe I would have been, it could have been more interesting attempting to do an RTS. Like, because a strong thing I noticed only after we began this project was I only put my attention on the fact that from really little beginning condition we end with a lot of different states. I think it could be interesting to make a simple game. It could have a lot of ending variables, so that's something that I think would be interesting to see in the future. And that's it.
All right, thanks a lot, Francesco, and all the team Barton. It has been a great idea linking together quantum games and quantum computing, music, and so on and so forth. By the way, this week is starting the first World Conference about quantum computing and music. So this is a hot topic at the moment. So we are very happy about having hosted one game in this jam about this subject. Okay, where are the experts? Are you showing up? Yeah, here are they all.
Experts of something, I guess, but yeah.
Well, you know, don't be too detailed, Jorge.
No, indeed, it was really good to see. I really appreciated the perspective of, because most of us here at least come from a quantum background, but of course the perspective of the jam as well is the fact that we want to be transversal and we want to be appealing to different communities coming from different sectors. So it's really nice that you guys that came from a totally different place found inspiring moments in just the learning process of the quantum part and how you connected that with music. So it was a perfect link with the heritage as well. So that was really cool to see.
Yeah, I think it's a good opportunity in these game jams to be something where people can play around with learning a new type of programming, both in game jams where people might try a new game engine, but also where people are trying a new kind of computing as here. So it's good to see that you had the opportunity to do that. I'm sorry that part of that was struggling with Qiskit, but it seems that you got some idea of how to use it in the end.
It was a bit, really, it was quite a bit of trouble, the setting up the Qiskit. I didn't think it would be so difficult because normally I would have, I am a bit, I don't have that much trouble with a program, but there was a bit of step to reach that. I have to say that once it started, we had pretty much no trouble apart from the one with the visualization. That's probably my fault because I am the one that made the guy. So yeah, it's mine most probably.
It was good to see the composer-like interface as well. I think that so it's nice in games when because that could now be used as a sort of educational game where people can make their first quantum circuit, but also get something nice and creative out at the end in terms of music.
Yeah, I have to say that it's great that you spent like almost all the weekend like understanding quantum computation, and then like yesterday night you were still without. I mean, you had a lot of ideas, but that's great that like in one night I went to sleep like at 1 something last night, and it was like all this stuff that we saw now wasn't there. Like the idea was there, but it's amazing how you can do like out of nothing this thing in one night.
I really need to thank you because without your help, we wouldn't have nothing mostly. We had the beginning idea we had was to use measurement to stop the circuit, and so you had the more notes in the middle of the circuit, but it seems like it's something that the composer do because it's a simulation, but it's something that should not be done. And without knowing it, we were going smiling towards destruction because we were absolutely sure that was something that we should have been able to do with Qiskit, while the problem was our understanding. Without Nicola, we really couldn't have had. We wouldn't have had nothing. Pretty much. Thank you very much.
I mean, we were all working in the backstage doing calls and stuff. Like we thought a lot. Also with Jorge and James helped a lot as well. So it was a teamwork.
But that's really one of the meanings and the wonderful situations in these quantum game jams, right? Because there is a lot of understanding and learning from each other. So that was really great. Thanks a lot, Francesco.
Thank you very much.
All right. So if there are no other comments and questions, this was our last team and our last game. And we are really approaching the end of the 2 hours that were allocated for this closing event of the second edition of the Quantum Game Jam hosted by Internet Festival. I think that it has been really an intense time during these 2 days. And of course, I'd like to thank everyone in the Internet Festival team. First of all, Michele Lanzo, who's behind the scenes. Michele, can you show up? Why don't you show up at some point?
He's in incognito, I think.
He's very
Never
shy.
shows up.
He's very shy. And of course, the scientific director and artistic director of Internet Festival, Adriana De Cesare, who's always very generous with us and very enthusiastic. Giangi Ferrari and Paolo Ferragina, who gave their speech in the opening event. And of course, to all the Finnish-Italian team who has been organizing, and a special thank to James Hutton, who's always just great and really makes all these occasions so valuable. And today also Zeki Seskir, who joined us. And I would ask for a really quick round of closing remarks from the organizing team. And then I can tell you that we also have a closing remark from Sabrina, but this will be really the last. So, Nick?
Yeah. So, I mean, it has been really a long weekend, but a fun one. Long in terms of hours being awake. I guess it's the same for everyone, but it was very fun, and I hope you get something about the quantum world, as far as to say. Maybe see you next year. Or
oh, sure we will. Sure we will. There is not a maybe. Okay, thanks a lot, Nicola. Nicola has been organizing since 1 month or even earlier all this. He did a great job, and we are really very happy about his commitment and his wonderful work. And also, Jorge, are you there? Indeed.
I am, yes.
So how is your perception of time?
I mean, it was my it was my first jam with you guys. It was really nice. I mean, the whole opportunity to talk to people that I've never actually talked with, game designers or developers before, and seeing all the amazing things they can come up with in such a short period of time is amazing. And the commitment as well, because they really put through the hours there and stay there up and work and suffer a little bit, but in the end it was worth it because they created such amazing things. And I think we can all remember this with a lot of love and appreciation, because it was such an amazing experience. So I'm really happy that I participated.
Great, Jorge. Thanks a lot also to you for all your work. And then Zeki, your final words for this jam, of course.
Yeah, thanks. It has been great seeing all the end products, and I really hope to continue these efforts like here and in other events and make quantum games mainstream one day.
Great, Zeki. Thanks a lot. And our collaboration will continue also with the pilot activities. And James, thank you so much.
Well, thanks for having me here again. It's always good to participate in quantum game jams. And thanks to all of the people who made games. I hope they all had fun and all learned something that will go into the long-term memory despite the lack of sleep. So yeah, it was good to see people's creativity around the idea of quantum computing. So thanks for all that.
Thanks a lot. Thanks a lot, James, and indeed thanks to all the jammers who really did a great job, and they made this quantum game jam alive, and we learned so much from them, and we enjoyed their creativity. And so now, Kate, is your turn, and then let us make Sab speaking, because she sent us, she sent us a video.
A last-minute video.
A last-minute video, unfortunately, because of reasons that will be very clear, because of external noise, she won't speak. She speaks, but we will not be able to hear her. But we do have the words she said, so we will say the voiceover under the video, right? So,
yes.
But in the meanwhile, Kate, please tell
I
your
wouldn't
words.
add so much, but a super big thank to all the jammers, to all the organizers. It was great. It's always great to have these vibes of creativity all around for a whole long weekend, as many people already said. So thanks. It's very, very inspiring, and let's keep in touch for what comes next.
Okay, Kate, so many thanks. And now I'm going to share the video about that Sab has sent. Can you see it?
No.
Oh, I see. Let me see whether I can find. Okay. I think that here I am.
Remember when you press
okay, can you see it? Can you see it now?
Probably. Yes.
Yes.
Okay, so here is Sab, and hello everyone. Happy to see you back. It has been great to be there with you and everywhere else at the same time. I'm going to make a quantum jump from my plane now. Thanks to all teams for the great job. See you at the next If Quantum game. The next If Quantum game, I'm coming, eh? The next If Quantum game jam!
Thank you, Marilu.
Okay, so we also have Sab's greetings, and so we can stop here. This crazy crew, I think, made the job. And let us see each other at the next If Quantum Game Jam. That will be next If. That will be, Michele, when it will be? So we ask him to be with us, but I don't know whether he will do it. So next October, anyway, October 2022. Thanks, Michele. He's writing the private chat. Okay, thanks to everyone, and ciao to the next.
Thank you.
Bye bye.
Thanks everyone. Bye bye.
Thank you.
Thank you.
Thanks. Bye.
Bye.